So for our lesson today, we are going to discuss how to divide a polynomial with a binomial. But the concept is very similar to factoring. As long as we know how to factor, the division will be very, very easy. So let's start by factoring your x squared plus 6x plus 8. So we have a trinomial. There's no GCF. Okay, we know that there's no GCF. I can't apply DOS because we have three terms. So this is a trinomial. We need to get factors of 8. The sum should be equal to 6. So what are those factors that will give you a sum of 6? All right, 4 and 2. So 4 times 2 is 8. 4 plus 2 is 6. So this is the correct combination. So we are going to get x plus 4 and then x plus 2. Okay, we're done with the first one. For the second one, check if you have any GCF. Do you think we have a GCF here?
Yeah.
Which is equal to? Good. So what's inside the parentheses then? X what?
4.
Good. Minus? Okay. All right. Next, let's check if this one can be factored. There's no more GCF here. Next, let's check if we have a difference of two squares. All right, we have two terms. I have a minus sign in between. Next, we have to check if this one is a perfect square and if this one is a perfect square. Okay? So can I write my x4 as quantity squared? Is there a way that we can write this as quantity squared? How? Should be x squared squared. Okay, remember that if I have xn raised to m, a product to a product, we can just multiply your exponents. Okay? So what about your 4? How can I write my 4 as a quantity squared? It will just be equal to 2. Alright? So this is a perfect square, it's a perfect square, so we have a difference of two squares. Don't forget to bring down your GCF. So I'll just write this as 4 and then a difference of two squares. To factor this one out, just copy the first term, x squared, and then this one, 2 and then 2. And then we just have to write plus and minus, or minus plus. Alright, so this will be your factors for 4x4 minus 16. Alright, next one. So go ahead and try to factor this. Okay, don't forget your GCF if you have any GCF. Alright, so note that for this question we have a common factor which is equal to, okay, what's inside the parentheses then? X squared minus 3x minus 4. Alright. This one, we have three terms. So it means that we have to solve this using a trinomial. Note that my last term is a negative 4. So we need factors of negative 4, one positive, one negative. The sum should be equal to negative 3, right? So what are the factors? Let's say the 4 first. Ignore the negative sign. Factors of 4 will be 1 and 4, 2 and 2. Okay? Now this one is negative. It means that one of the factors should be negative. Okay? Now you check the middle term. The middle term is negative. So the bigger number will be the one that will take the sign of the middle term. Okay? So which one is bigger, 1 or 4? So 4 will be the negative sign. We'll take the negative sign. Now these two are the same, so it doesn't really matter where to put the negative sign. I can just put it here. Now which one will give you a sum of negative 3? Okay, this one, okay, will give you a sum of negative 3. So your factors will be x plus 1 and then x minus 4. Don't forget your GCF. Okay. Alright, next question. Here we go. Although we know that we have a trinomial here, make sure that you follow the routine. Check if you have any GCF. Alright, there's no GCF, correct? What about your difference of two squares? Now, because we have here three terms, so we have to apply our trinomial. I have one here, so I don't need to use slide and divide. So I just have to factor 25. We need to get factors of 25, wherein the sum of those two factors should be equal to 10. So what are those factors then? 5 and 5. Okay, so we get x plus 5 times x plus 5. Of course, if you don't see this as an option, try to check if you have x plus 5 squared, because these two are the same thing. Okay? So this is, factoring is very, very important when you divide a polynomial with a binomial. Okay? And that's our lesson for today. So here we go. How do we divide a polynomial by a binomial? But before we do this, let's try to remember how to divide a polynomial by a monomial. Just want to make sure that you remember how to divide, let's say this one, polynomial with a monomial. It's a monomial because you only have one term. Okay? So how do we divide? We just have to distribute our, not really distribute, but separate our numerator and just divide by our divisor. So plus 50 and 7, then divided by 10 and squared, plus 50 and 6 divided by 10 and squared. Okay? And when we divide, what's 10 divided by 10? That's 1. And 8 divided by n squared is, and 6. Remember, we have to subtract. What about this? 50 divided by 10. Okay. N raised to 5. Nice. 50 divided by 10 by 5. Then n6 divided by n squared and 4. So this is how we divide before. Okay. That's if you're going to divide with a monomial. This time, we are going to divide with a binomial. Okay. It's kind of different. Instead of us separating our numerator, we have to factor the numerator and then divide by x plus 4. Note that these are the same. We might give you a question like this. X squared plus 6x plus 8 divided by x plus 4. Or it could also be this. Or you can also have x squared plus 6x plus 8 divided by x plus 4. Okay? So these three mean the same thing. So how do we divide with a binomial? Well, just try to factor your numerator. And we already finished factoring the numerator earlier. Okay? So just factor your numerator. We got x plus 4, x plus 2, and then divide by x plus 4. Okay? Now we have the same, I have a factor of x plus 4 and a factor of x plus 4 at the bottom. So we can cancel this, and then we're going to get x plus 2. So this will be our quotient. X plus 2 will be your answer. Now note that we can only cancel if we have a product with the factor that you're going to cancel and with the rest of the expression. So this one, we can cancel x plus 4 and x plus 4 because this x plus 4 is being multiplied to x plus 2. So that you'll understand this better, let me give you an example in terms of numbers. So let's say if we have 4 times 2 divided by 2, and then 4 plus 2 divided by 2. So this is a product. So we're allowed to cancel this and this because 2 is being multiplied with this expression, okay, which is equal to 4, which makes sense because this is 8 divided by 2 is indeed equal to 4. Now, if you have a plus sign, okay, you cannot cancel this and this because this number here that you canceled is added to 4. You can only cancel if that expression that you would like to cancel is being multiplied to a different number or different factor. So this one is not allowed. You cannot just cancel 2 and 2. Okay? So if we have, let's say, x plus 8 divided by 8, we cannot cancel 8 and 8. That's wrong. There's no way that we can cancel this. Unless, let's say you have 8x divided by 8, okay? Then we are allowed to cancel the 8 and 8 and say it is equal to x. Okay? So just be careful, okay? When you're canceling, it seems like they're going away. But actually, x plus 4 divided by x plus 4 is just equal to 1. It's equal to 1. And then 1 times x plus 2 will just give you x plus 2. Okay? So I hope that you will not forget that when you cancel something, just like this one, 2 divided by 2, that's just equal to 1. And 4 times 1 will be equal to 4. Alright? So this is very, very important. I don't want you to cancel like you notice that we had the same expression, top and bottom, you will cancel right away. No, please don't do that. Just make sure first that the one that you're going to cancel is being multiplied with another expression, okay, before you can cancel. Right, so there we go. That's how we divide. So look at this question here. 4x4 minus 16 divided by x squared plus 2. Remember this expression earlier? We factored this earlier. What was the factor again? Here was the factor. Okay, over here. So what you need to do is just rewrite this into 4 x squared minus 2 x squared plus 2 divided by x squared plus 2. Okay. Now note that this 4 is multiplied to your x squared minus 2 multiplied to x squared plus 2. So now before you cancel this, make sure that the one that you're going to cancel here is being multiplied with the rest of the expression. So this one is multiplication, so we can just cancel this and cancel this one. So the quotient or the answer for this question is 4 times x squared minus 2. So if you notice, as long as you remember how to factor, the division is just a matter of canceling the common factor in the numerator and in the denominator. Okay, so that's the only thing that we have to remember. Alright, and then finally, for this question, we also already factored the 2x squared minus 6x minus 8. If you remember the factor, it's this. So your numerator is 2 times x plus 1 x minus 4, and we are dividing this by your x minus 4. So actually we already finished factoring your numerator, so it should be very easy now how to divide. So again, we are trying to cancel the x minus 4 and x minus 4. Before I forget, the x minus 4 in the denominator, you might see in our test or in your SOL test, they will say that your x will not be equal to 4. You will see this one as a restriction. Okay, this is just an information that your x will never be equal to 4. Why? Because if x is equal to 4, what's going to happen to this? It will become 0. And we're not allowed to divide by 0. And if this will be 0, you'll get undefined. So that's why they always put x not equal to 4. Or any value of x that will make your denominator will be equal to 0 will be restricted. Okay? But when you take your test, we have to write this one, but I hope that you will not be bothered with this. Okay? Just an information. Alright? So now we can cancel this. We can cancel this. And what do we have? 2 times x plus 1. Okay? And finally, before we go, we also factor this already. Okay? X squared plus 10x plus 25. You remember the factor for this? This is equal to what? X plus 5. Alright, x plus 5. Then divide by x plus 5. So again, you will see an information x should not be equal to negative 5. Okay. So we can just cancel this one out and then say x plus 5 will be our answer. Alright? So there we go. That's your division of polynomial with a binomial. So for our next example, I would like to show you an example in terms of numbers so that you know how to simplify or divide a polynomial, and then your divisor should also be simplified. Okay, so here 75 over 50. How do you get your answer 3 over 2? We know that 75 is what? 25 times 3, right? And then 50 is 25 times 2, correct? And then from here, this is product. So we can cancel this. 25 over 25 is just equal to 1. Okay? And then 1 times 3 over 2 will just give us 3 over 2. But the concept here is that to simplify a given quotient or division problem, sometimes we have to factor out the numerator and factor out the denominator and then cancel any common factor in the numerator and denominator. Okay? I would like to emphasize though, so if we have, let's say 2 times 3 times 2, and I have here over 5, for example. This is a different question. Are we allowed to cancel 2 and 2? Because some of you might think, oh, we have the same number here, so I can cancel the 2 and 2 here. No, okay? Make sure that one is in the numerator and the other one is in the denominator. We're just canceling this one because we know that it's equal to 1. Okay? Alright, so there we go. Alright, go ahead and simplify this. This time you have to simplify the polynomial. Same thing with your divisor binomial. Before you can cancel something. By solving this question. Alright, so do we have any GCF there? For this one? 4. This one, yeah, I think 4. So we'll get n squared here minus what? 6n plus, good, 8. Okay. And then I think we can factor this. What are the factors of 8 that will give you a sum of negative 6? Alright, so it should be both negative, okay? Negative 2 and negative 4. Remember that if this is positive, the factor or the sign of the factors should be the same sign as your middle term. Alright, so since this one is negative, then both factors should have a negative sign. So we are going to get 4n minus 2 and then n minus 4. Okay, we're done factoring the numerator. What about your denominator? Do you have any GCF here? Yes, you have 4. We'll get n minus. Okay. Just like what we did earlier, we tried to factor 50 into 25 and 2. That's what we did here. We factored the 4n minus 8. Now, note that I have 4 times n minus 2 times n minus 4. 4 times n minus 2. So, we are allowed to cancel n minus 2 because n minus 2 is being multiplied to n minus 4. N minus 2 is being multiplied to 4. Okay? So, you can cancel this one. Of course, again, you are going to see n should not be equal to positive 2. Because we don't want your denominator to be equal to 0. What else can we cancel? 4. Cancel 4. So we are going to get n minus 4 as our final answer. Okay? Alright, so before we leave, let's try to answer this question. So again, we're dividing this polynomial with a binomial. So let's start by factoring your numerator. Note that we have a GCF, which is 2. I'll get here 2x squared plus 11x plus 15. We're dividing this by 4x plus 10, which we can factor using a greatest common factor GCF. I have a GCF of 2 here. So we are going to get 2x plus 5. Okay. Now let's try to factor this one. Okay. So this is a trinomial wherein my a is not equal to 1. So let's use our slide and divide. So multiply 15 by 2, we'll get 30. We need to get factors of 30 that will give you a sum of 11. So what are those factors that will give you a sum of 11? It'll be 6 and 5. Alright, so we'll get x plus 6, x plus 5. But since we use slide and divide, we have to use the number, we have to use your a, which is 2, to divide your 6 and then your 5. We can simplify your 6 over 2 as 3. We can simplify 5 over 2, so we have to just move our 2 beside your x. That's 5. And don't forget to bring down your GCF. You're dividing by 2 times 2x plus 5. So we can cancel this. And we can also cancel 2x plus 5. So your answer will be x plus 3. And again, during our test, you might see something like this. X is not equal to negative 5 over 2. Just to make sure that your denominator will not be equal to 0. Oh, sorry, x is not equal to negative 5 over 2. Okay? They'll always have to include this one just to make sure that you will not have undefined, meaning your denominator will not be equal to 0. Alright, so there we go. Okay, so let's go over the common mistake in our quiz. Okay, so some of you tried to factor this one, but we cannot factor this because there's no GCF in the first. There's no GCF. This is not a DOS. It's not a minus sign, so we can't factor this one using difference of two squares. It's not trinomial, so we cannot factor this one. So therefore, it will be prime. Okay. Now, if the question was 9 g squared minus 64 z squared, then we can factor it. It's a DOS. This one can be written as this, and this one can be written as this. So let's say I have a minus sign here. What should be inside the parentheses so that I can rewrite this as quantity squared? Okay, 3 and then g. What about here? So 8 and then z. And then there you go. We can apply your DOS, which is, if this will be your question, the answer will be letter A. Okay? But since this is a plus, then we cannot factor. And then number 10, identify all prime polynomial, meaning something that can't be factored. Alright, this one we can factor this one. This is x squared minus 1 squared. Okay. Careful with the minus 1. Okay, minus 1 is the same thing as negative 1 or minus 1 squared. But if you have, let's say, a negative 1 quantity squared, the entire thing was raised to 2, then this is equal to 1. So don't be confused with this. Okay, negative 1 or minus 1 can be written as negative 1 squared. Okay, so we can factor this. That's x plus 1, x minus 1. This one we cannot factor this one. Okay, we have two terms. There's no GCF. I can't use DOS. Why? Because that's a plus sign. Okay, so we can apply DOS. I can't use trinomial because I have two terms. Okay, what else? Let's try A. So x squared plus 6x plus 6. Factors of 6 that will give you a sum of 6. If you want, start with 1 and 6. After 1 and 6, what's next? 2 and 3. I think these are the only factors of 6, right? So none of this will give you a sum of 6. So A will also be prime. Now what about your B? So 2x squared plus 4x plus 8. Can I just right away use my slide and divide? No, right? Because I have a what? I have a GCF. So when you factor out your GCF, what do we have? X squared plus what? 2x plus 4. Since you have a GCF, you don't need to factor this. You know that you can factor B, so it's not prime. So for number 10, it should be only A and C. Okay? So we have a GCF, which is 4 times r squared minus 1. Now check if this can be factored more. Can we still factor this one? Do we have there's no GCF. Let's check if this one is the difference of two squares. I have two terms. I have a minus sign in between. Is this perfect? How do we know if a variable is a perfect? If the exponent is even. So it is perfect. What about 1? Is 1 perfect?
Yes.
Yes, because 1 is just equal to 1 squared. Okay? Negative 1 can be written as negative 1 squared. Okay? But if you have, let's say, a negative 1 quantity squared, this is different. Okay? This would be equal to a positive 1. But if you have a minus 1 or minus 1 squared, this squared here is just only for your 1. The negative here is not included. But if you have a parenthesis, then the negative is inside the parenthesis, meaning the negative is inside the exponent 2. So that's when you're going to get positive 1. Because this one means negative 1 times negative 1. This one means negative 1 squared is just 1 times 1, which is negative 1. Okay, so that I know you're confused about the minus 1. Is it really equal to negative 1 squared? Yes, these two are really equal. So we have a perfect square here, so we can have then difference of two squares. So r here and r, 1 and 1, so plus and minus. So there we go. So the factor should be 4. Oh, it says which one is the factor. If you have 4, you have to circle 4. R plus 1, it's a factor. Okay. R minus 1, we're just looking for one of the factors. So that's how we answer number 1. Okay. Next common mistake, it's number 5. Okay. So this one, we have two terms. So most of the time, if you have two terms, it's only either GCF or DOS. Okay. Do we have any GCF here, guys? 125 and 20. 5? What about 5? Can the 5 go out? Okay, what's 125 divided by 5? 25? Alright, so let's try that one. So bring out your 20, bring out your 5. We'll get 25, you said? And then what about your 20? It become, what about your variable, y and a? Do you have any common factor for y and a? No, right? So just bring down your y squared and then a squared. Now your next task is to check if this one can be written as quantity squared. 5 what? Y? Because 5 times 5 is 25. Y times y is y squared. What about for a squared? 2 what? Alright, so there we go. We have a perfect square. So your answer should be 5. Just copy the 5y. Then the 2a plus minus or minus plus. So find all simplified factors. So 5 is one of the factors. 5y plus 2a. And then 5y minus 2a. Okay? So that's how we answer this question. Next, I have number 6. Find all the factors of 5x squared minus 35x plus 50. Alright, so do you have any GCF here, guys? 5. Okay, let's bring out your GCF. So what do we have inside? X squared minus what? 7x plus. Alright, now let's get the factors of 10. That will give you a sum of negative 7. Should be positive or negative? Should be, if this one is positive, the sign of the factor should be the same sign as the middle term. So both negative. So there we go. That's all that we need to do. 5x minus, or maybe you forgot the GCF. That's why. So find all the factors. So what do we have? We have the 5. We have the x minus 2. And then x minus 5. So these are the common mistakes. So it seems like the DOS. And then, I think that's the only one. Alright, so go ahead and check your, this is the answer key.